Building the catcher game, we have our 4 core classes that we're beginning with right now. We'll have the primary game class, we'll have our catcher, we'll have the drop, and then our timer. The timer we keep separate so we can control it, because there isn't a built-in clock that is in the language that we can use that already has methods associated with it. So we have to build what is in essence our own stopwatch. And that's really what the timer will be. But we'll start out with the catcher because that's probably the easiest class that we're going to be working with. And the catcher will have a radius. It will have an X and Y position. So we need to provide it with those values so that we can use it. Now, you will notice that the catcher's constructor method. The constructor method, when we see it, it has a value that's being passed to it. So in my main game, if I say catcher is equal to new catcher, it's expecting me to provide a number. It wants to know what is that radius that is being sent to the catcher when I make it. So I can decide how big I want it to be. Do I want it to be 50? Do I want it to be 100, 200? Well, probably not that big because it's going to be too big on screen. So I have to figure out how big I want that to be when I put it in to the game. So a decent size based on the size drop we'll work with. We can give it a radius of 16. So we'll just say catcher. So our constructor in the catcher was waiting for that value. Then we can say our radius for this object is that temp radius. Now we could skip that whole process and say, and we don't need to pass that in. We can just hard code the value inside the catcher class. But I did it this way because then on the drop we won't do it. The drop will just be a new drop. Just so we can remember that there's different ways to work with our constructors. So our constructor, we can pass in a bunch of values. We can pass in random positions, random colors, and all of that can happen in our main class when it's creating new objects, or the properties of the object are determined by their own class. So we can work in both methods. Now the next thing we're going to do is decide we want our catcher to show up at a specific location. Now I want it to start out at the beginning of the middle of my screen. So I will say I want my X to be at the width of my sketch divided by 2, and I will want the Y to be at the height divided by 2. So that will now position it on screen at those locations. The next part gets pretty straightforward, that we get to specify that we are updating this position. So we will say X is equal to the mouse X. Y is going to be equal to mouse Y. So we're updating its position. Finally, we get to set up in our display. We can specify a color. And I will just go gray for now. You can choose a more interesting color, but I will use a basic boring middle gray. Now I will draw an ellipse at x, comma, y, comma, and then r times 2 and r times 2. So the times 2 is because we are using a radius value. Now the reason we are using a radius, because ellipses will draw, when we specify width and height for my ellipse, that is the diameter of the ellipse. It's the dimension all the way across. But when we are trying to find out, have objects intersected or run into each other, we need to instead be working with half of their width, or in this case their radius. So we're working with the radius of the object instead of the full width of it. So that's why we will start with that value and multiply it by 2. At this point, I can go into my game, and just to prove that we have something running, we can say catcher.update, catcher.display. And when we do that and hit run, well, my timer is waiting for something to happen. I'm just going to put that in for now. We'll figure out the rest of why and how in a moment. When my sketch comes up, we can see I have my catcher object is moving around on screen. Well, notice there's a few things missing here. Because the sketch is missing a few things, we do need to complete our obligation. So I will specify sizing. Now if I run my sketch, we'll see that, okay, it's kind of working, except that we can see my catcher object on screen continually. So we do need to utilize a background clearing function. Background 255. And at the beginning of draw, specify clear background. By doing that, we've now wiped the slate clean and then redraw the catcher when I run the sketch. Now it's behaving a little bit better. It's giving me a much better visual. So we can see that that ellipse is starting to follow my mouse. Now the timer object, and we'll get into the timer after we add in the drops, because we will want the timer to control the release of the drops. But just a little bit about why when the compiler read this code, and when this line wasn't here, it read the code and said, okay, there's some code, and every one of our functions says void in the name of the function. Meaning that function doesn't give us anything back when it's done. It just executes. It just does whatever those instructions are. But this function says boolean, which means when this function executes or runs, it's supposed to tell us something. And it gives us back a boolean, and booleans have one of two values, true or false. And because we didn't specify what is coming back by using the statement return, and then I could say return true or return false. Those would be my two options. Because I didn't have that there, processing got grumpy and said, whoa, hey, what's going on here? You told me this is supposed to give me a boolean. Where is it? So we have to help it out a little bit so that that function is complete. If it says void, the function doesn't need to do anything. But if it says boolean, it needs to give us back something. If we go back to the main game, we will notice that our intersect function, which has been provided for you, and we will talk about once we have a drop to worry about, we will see that it does indeed have return true or return false in it. And those values come back depending on whether the objects have or have not intersected each other. Inside the drop class, now we need to define out the drop class. When we look at what is happening within the drop class, we can see that a couple methods have been predefined, and then the constructor is waiting for us to do something. So the first thing I am going to do is define the x and y location for my object. And I will set my x equal to a random value that is the width of my sketch. This will pose a problem down the road because it's possible to get a value of 0, which means my drop will be half on screen, half off screen. And it's possible to get a value that is up to, but not including, but for all intents and purposes, the far right side of my screen, so it will be half on, half off. So if we want our drops to stay on screen, we need to modify, instead of saying width, and we could change that value a little bit, and we could set it equal to R and width minus R. And what that means is it will now keep it on screen. But there is one problem doing the line here, is that R does not have a value yet. So I will need to go right above it and say R is equal to, and I've decided my drops will have a radius of 8. So that now means my random position that it can appear will be between 8 and the width of my sketch minus 8, which the width is 600. So now we've defined R, we've defined X, we can define Y. And Y, what is nice here is to set it off screen. So if we want to set it off screen, that means we need to be at something less than 0. Because if we say 0, that means the drop will appear half on screen, half off screen. So we need to be less than that. So a convenient way is to tie that distance off screen to the radius. So we'll see negative R times, and just choose a nice round number like 4. That's what the book used. It works. So that means our drops will appear at negative 32 above our sketch. That means they're off screen to the top. Now we can decide that our speed Y is going to be a random number between 1 and 5. And what that does is that sets our speed between 1 and up to but not including 5. So there's some variance, so some drops will be fast, some drops will be super pokey. Now when it comes time to defining your game, it's important that you change these values to be reflective of your content. So if it makes sense that your content is moving fast, you should have higher numbers. If it means your content is moving slow, leaves or feathers are falling from the sky, then you will possibly want to be, say, speed of 1 to 2 or 0.5 to 1 if you want it really painfully slow. So it all will depend on what you view as necessary for building your game. Finally, as I look at my list of variables up here, X, Y, R, speed, Y, and now we have C. C is going to be our fill color. And we will set that equal to color. And if I choose a minimal red, a minimal green, and then a random blue that has a range in my blues, that is going to give me variations on blue for my coloring as part of this. So we have our radius of 8. X will be random. It will be on screen to the full width of the screen, but not off screen. It'll be positioned above our sketch to start. And then we have our speed of somewhere between 1 and 5 and a random variation of blue for our coloring. Now, because the drops are only falling down in this example, we don't have a speed X. If our drops were going to be moving side to side, it would be speed X, even if they're, say, wiggling or jittering on screen. Then we would have a speed X and we'd be calculating and working with that as well. Now, I'm going to say Y plus equals speed Y to update our position. Now, if we do nothing else in our update and we don't have it checked boundaries as a separated function in this example, that means the object is going to just fall off the screen and never come back. If we want it to screen wrap, then we have to ask the computer the question. If Y is greater than height, Now we may want to keep in mind that if I say height, that's at the bottom, so that means the drop is still half on screen. So we may want a number a little bit bigger than height. So we could add to it r times 4. So once it's 32 pixels beyond the bottom of the screen, at that point, curly brace, return twice, curly brace, up arrow, and now what we can do is set y equal to r, negative r times 4. So it's the same starting value that we did before, but now it's back up screen. And don't forget to always put the semicolon at the end of a line. But when you're doing an if statement, don't put a semicolon after the parentheses before the curly brace, otherwise your if statement will break. Same thing on a for loop.
In other words,
so the drop can construct itself, can update itself, but it can't show itself on screen yet. But if we set our fill color, then we can draw it on screen at x, comma, y, comma, r, just like the catcher times 2, r times 2. So now our drop can update, our drop can display on screen. We'll worry about caught and reset and how to utilize those as we develop our game. So we have a catcher, we have the drop, now we have the game. But the game doesn't have any populated drops yet, so we need to add those into the game to make the fun start to happen. To add in the drops, we will use, first we need to finish defining drops. So we say drops is equal to new drop, square bracket, and now we get to decide how many drops. Now we could say, 20 or 50 or 25 or some value. But you will notice that there's a variable up here called number of drops or num drops. The reason for that is we can reference this number or use this number hard-coded in multiple times in our program. But because it makes sense to be able to change it in one location, so I want to go from 25 to 50 to 100 or 1,000 drops, it's easier to set a variable equal to that value. So if I say num drops is equal to 25, then here I will just say num drops. And now we are going to do something a little bit different than what we did on the 1,000 object project. This time, instead of talking about drops.length, we can just start using this variable num drops when we write our for loop. So for int I is equal to 0, I is less than the number of drops, I plus plus, and then drops I is equal to new drop. It's really easy when you are typing this to forget to add the plural on your array name, so you say drop instead of drops. So that's a common thing that happens when you are coding, that you miss an S and then your code breaks. And you're like, why is this happening? It looks the same and it looks close. And that's okay. But we just find a way to make it work. The next thing is to add in a loop to go through all of our drops. And it's the same for loop that I have up here, except instead of creating new drops, we'll be telling each drop to update and then telling each drop to display. So you can copy paste, or you can just type it in again. and both are fine. It doesn't really, if you want to copy paste, that's great. If you want to type to make sure you are kind of cementing in your brain the syntax of how to write it, that's fine too. So each drop is told to update and display. So I clear the background, catcher updates and displays, my drops update and display. If I run, we'll see that all the drops start falling from the sky. Because we are going to be trying to catch the drops and want to make something happen with that, we need to find out, has a drop been caught? And if a drop is caught, we need to make something happen. Now, one of the easiest things that we can do is we can set a score. And this also allows us to introduce the concept of displaying text on screen, which is kind of cool. So we're going to set up a score and show the score on screen. And then every time we catch a drop, we're going to make the score go up. So we can see how that works. So when setting up a score, what we need to do is we need to have two things. One, we need to store the score in a variable. Well, our score is going to be a whole number, so it will be an int. And I'll call it score. Then what I also want to have is I want to have a string. The string is going to be the letters, the words that I show on screen for that score. So I just want to create that as a variable now. So I'll say string s. I could give it a longer name, but s is good enough. It gives us a starting point. It gives us the value that we need to begin. Now when my game begins, my score will be 0. And s will just be equal to an empty string. We will give it a value in a little bit where we will define what s is and then say, I want to see s on screen. And that's going to happen inside our draw function. Now, if I put it first, objects will sit on top of it. So remembering that we clear the background, then I'm drawing the catcher, then I'm drawing the drops, then I want to show my text on screen. Now, I want to assign a color to it. So I will set my color, and I will just give myself red text because I can. And now I will set the value of that string s. And I will set it equal to score, colon, and I'll put a space so that the numbers are spaced a little bit away from the word score. And then I'm going to attach to it that score variable. So currently that would be score colon space and the number 0. Then to make my text appear on screen, I simply use the text command or method. And then I specify what text I want to appear on screen. And then I can specify where I want it to appear on screen. If I run my sketch, we will see that it shows up in the top left corner of my screen, and the drops fall behind it. The catcher is behind it. So now I have text appearing on screen, but not much is happening. So now what we want to do is we want to find out, have any drops intersected the catcher. Down at the bottom in the game file, you will see that there is the intersect function. And it returns a value. It returns a value of true or false. And what this does is it calculates the distance between the center of the catcher and the center of the drop. And then it compares that to the radius of the catcher plus the radius of the drop. Two round objects. The black line represents the radius of each object. We can see at their center points. So if I take the distance between these objects, between their center points, and compare that distance to the two radii of the object. So if I put one object here, if the distance between their centers is greater than radius 1 plus radius 2, the objects aren't touching. But if the distance between these two objects is such that radius 1 plus radius 2 is bigger than the distance between where their centers were, that means those objects must be intersecting. They're overlapping each other. So knowing that in processing, if the distance between object 1 and object 2, and that's what this calculates. It says object 1, which is A, and object 2, which is B. That's the two centers. If that distance is less than the radius of A plus the radius of B, they've intersected, return true. Else, they're not intersecting, therefore return false. The intersect function takes two values. We pass in the catcher, we pass in a drop, and then we do this calculation. So if I have 1,000 drops, it has to do it 1,000 times. So if you do that, this isn't the most efficient way of going about doing this. But in our project where we're only going to have 25 to 50 drops, most likely, this should work just fine. We're doing a one-to-one or a one-to-many comparison. We take one object compared to all the other objects in the array, which if we have 1,000 objects, that's a bad use of resources. In this case, it's fine. So intersect, we pass in two objects and it sends us back a value. So going back into my draw function where I've told the drop to update, I've told a drop to display, now I'm going to ask a question. And I'm going to say if intersect catcher and the current drop, which is drops I, if that is equal to true, meaning the two objects are intersecting, I want my score to go up by 1, and we should see something happen. Because on the next line, it's going to now show, not next line, but a little further down, it will show us the value of score. So if we run this and the drops start falling, we can see how the score goes up. Now I can cheat and stay on a slow moving drop, and well, gee. That's kind of a broken game in that I can run up the score ridiculously because the drops aren't responding. My score is going up, but it would make sense that if I've caught a drop, it should go away. So now we need the drop to go away. And that's going to be our next task, is figuring out how to make the drop go away. Conveniently, inside the drop class, you will see that there is a stubbed out function called caught. And that's what we're going to look at next. We want the drop to be caught. So inside the game, after we update the score, I want to say drops I dot caught. So we'll tell the drop it's been caught. Now if a drop has been caught, at this point, what we could do is say y is equal to negative r times 4. That puts it back up off screen. But the drop is going to fall again. So we haven't eliminated it, so I can score forever. We could also make the drop disappear off screen and stop moving if we want to make our game about clearing the screen instead of playing forever. And we'll look at that in just a moment. But when you're doing things like this, it makes sense to test often. So you add a line or two of code and you keep testing. So here it looks like I'm catching things, but it's not, I'm not seeing a lot of change happen except that I'm catching and my score is going up. But if I were to try something like speed y is equal to 0, now, and I'm going to modify this location, y is equal to 0, meaning they will be half on screen. So now when I catch one, we can see how they park up at the top. And eventually, I've caught them all. I caught all 25 falling drops. I don't have a reset. It's not doing anything else, but at least I caught them. Now, if I decide I want a better score, I can just start putting my cursor across the top while they're parked there and watch my score going up, but that's cheating, and that would be bad form. As we've worked with our game, we can catch the drops stop, they go up to the top of the screen. Effectively, the drop is now dead, our score goes up. And in a subsequent session, we're going to learn about how to deal with catching all of the drops or not catching all the drops. So effectively, how to win and how to lose. And we're going to introduce that into it. But first, we want to control it so that when our game runs, it doesn't create the monsoon effect where all the drops start falling at once, because that's just not that exciting. So what we want to have happen is we want the drops to drop out based on a time interval. So we're going to have to do things a little bit different and introduce a few extra variables. But the first thing required will be to work with our timer. So we need to define out the rest of the timer object to give it some values. Now, when working with the timer, what we need to figure out is how long the timer is going to run. And we're going to give the timer an interval and set it equal to the value passed in of time interval. We'll learn what that time interval we sent to it is in just a little bit. But when we tell a timer to start, what we're able to do is we will say start time is equal to millis. Now, what that means is processing has a built-in method or function. Just about every programming language has something along these lines where we can ask the computer and say, how long have you been running? So how long has this program been running? So we can ask the computer, how long have you been running? Now, if we keep track of that as a starting value, then effectively know what was our start time. And then if we ask it at a future point down the road and say, hey, how long have you been running now? And then we subtract those two numbers, we know what is the current time. So has our program been running for 1 second? Has it been running for 2 seconds? Has it been running for 3? So we can figure out that elapsed time. And that's what's going to matter in our complete method. So complete, we're going to keep asking the timer. We're going to say, hey, are you done yet? Hey, are you done yet? Hey, are you done? And we'll keep asking it in the timer. We are going to figure out our elapsed time. And we're going to say elapsed time is how long the program has been running. So we're asking that question again and subtracting from that our starting time. So that is how long the program has been in use. Then we will say if elapsed time is greater than the interval that we are checking for, then we will return true. Else, we will return false. So if the program has been running longer than the interval we passed in, so if we say, I want my timer to run for 1 second. So then 60 times a second, processing is going to ask the question, are you done yet? Are you done yet? And when 1 second of time has passed, that means our elapsed time is now going to be greater than that interval, and it will return true. Otherwise, every time we keep asking this, if a second hasn't passed yet, it keeps telling us, nope, 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 not done yet, not done yet, not there yet, until it finally is true, and then it switches over. The good part about the timer, now that we've completed all of this hard work of entering in this information, we don't have to touch it ever again. The bad part about that is we start to forget, how does it actually work? Keep in mind the computer counts in milliseconds. So it's giving us thousandths of a second. And it just keeps giving us time. The program starts running, and millis is at 0, and then it just keeps counting up as long as it keeps running. So every time we ask the question, millis, this in blue, millis with parentheses, we're asking it, how long have you been alive? How long? And it just tells us, I've been alive for that many milliseconds. So we just keep asking it that question over and over and over until we get the result we want, which is our elapsed time will be greater than the interval that we are working with. So that's the timer class. We can move away from it to never have to visit it again. You can, but we don't have to. Now we need to do something with it. Currently, if you look at your main game, it doesn't reference the timer at all. It doesn't ask it anything. So we will need to make a timer object and do something with it. So we will need a new timer object. So I'll reference the timer class, and I'll just call my timer variable timer. Then we are going to need a value that will be an integer, and that will be our time interval. So we're going to pass in that value because the timer class is expecting an interval. So we're going to pass that into it. We're also going to need another value that we will get to in a moment, but we might as well give it information now. And it's called active drops. This is how many drops are currently active. So when our game starts, there will be 0 drops falling. So it will come up and there won't be any drops there. And then it will hit 1 second, it will drop one down. 2 seconds, it's going to drop another one. 3 seconds, another. And it will just keep going. Or maybe a second is too long and we'll say every half second or every quarter second or every 2 seconds. It really depends on what your game is going to need. So now I'm going to need to give these all values. And to do that, I will, in my setup, I'll just go down to the end of setup here. And I can say active drops is equal to 0. My time interval, I will set equal to 1,000. That's 1,000 milliseconds or 1 second. So the computer counts in thousandths of a second. So 1,000 is 1 second. So that will be our time interval. Then I'm going to actually populate my timer variable. Say timer is equal to new timer. And then I will pass in that time interval. The timer to start. Now if I do this and run my sketch, we will see exactly nothing different. But it would be a good time to run the sketch right now to verify that I don't have any other errors in my code. When you add in blocks of new programming, run your sketch frequently so that you don't accidentally have multiple errors that make it very hard to track down. Add in a little bit, run. Add in a little bit, run. That will prevent you from causing issues down the road. So it's really important to get into that practice. All of my timer information has been set. Now we need to incorporate it into our draw. Currently, inside draw, the number of drops falling down is the maximum number of drops. But what we really want to have happen is I want the number of active drops to start falling. Instead of all of them to go through at once, I only want one to fall. And then I want 2 active. Then I want 3 active. And this is how we're going to use the timer to pull this off. So I will change inside my for loop, I will change it to active drops. Now if I run my sketch this time, I will see something different. And what I see is nothing falling down. You may think that I broke the program, but I haven't. I just haven't figured out a way to make active drops increase based on the timer. And that's what I want to incorporate into it now. What I can say is if the timer is complete, so if timer complete is equal to true, now we say timer complete and we put parentheses. So we're asking the timer method, looking at the timer class, or I mean the complete method. And the complete method returns true or returns false. And it returns true when my elapsed time has passed my interval. Now in my game, my interval is 1 second. So when the elapsed time has passed of 1 second, that will make this true. So if timer complete is true, we can say active drops plus plus. Make active drops go up by 1. Then we can tell the timer to start again. I'm going to comment that out for just a moment and just run this, and we're going to see some interesting things happen. So if I run it, we'll notice all the drops fell and then my program crashed. So that's bad. Now we get out of array index out of bounds exception 25. So what has happened is my program has tried to use active drops at too high a number because it actually reached active drops went to 26. And when active drops hits 26, that's more drops than my game has, so it gave me an error message because I tried to access item number 26 in a 25 item array. And that's what the out of index error message will always mean, is your programming is generally off by 1 number and you tried to get something beyond what exists in your array. Now, if I change this back to start, every time the timer starts, that means it's not done. So if the timer is running and it's not done, it goes until it hits 1 second. And then the timer complete, it goes, hey, timer complete is true. And I tell the timer to start. That's like hitting reset on my stopwatch. It's now back down to 0. And it counts back up again. Now if I run this, let's see, 1, 2, and what we will have to do is wait, and after 25 seconds, when all 25 drops are falling, and I'm trying to avoid any of them just for fun to get a score of 0 before when it crashes. So once all 25 are running, then I will get the out of index error message once more. Now that was pretty slow for them all to eat between drops. So I think I might modify my interval to a ½ second. So 500 milliseconds instead of 1,000 milliseconds. So if I do a ½ second, it's going to fall faster. But it still has the problem that I will have all the drops falling, and then I will try to access the 26th drop, which doesn't exist, and my program will crash. There, it crashed once more. So what we need to do is only make active drops go up as long as active drops is less than my number of drops, because then it won't get too big. So if we say if active drops is less than my number of drops, then I can move this line from here up to here. So if active drops is less than my number of drops, then I make active drops go up. But it won't go up past the number of drops, because once active drops is equal to the number of drops, it's not going to keep making it go bigger. So now I've created my program that it won't crash. And I will shorten up my interval here so they come out faster. And now we can see even that at 100 milliseconds, or a tenth of a second delay between them, that's better than the monsoon where they all start in at the same time. So staggering the objects, it creates a much more natural progression. There, cut all 25. Now I can still cheat on my score because they're on screen. I can still keep my score going up, so that is bad form.